Hey viewers, so here's my newest laser project in the works here. This is another 405 nanometer violet near UV laser. It has a good far down range in the far field. It hits about 12 to 13 feet before it diverges outwards. But it's a decent range at about 7 to 8 feet and can be used for fluorescence experiments. And I'm using a computer power supply here that I removed from a old broken computer as the power source for the laser. This power supply is rated for 330 watts of power and also operates on mostly passive power factor correction. So as for the driver, it's really quite simple. I'm using the LM33AT semiconductor as the chief component here. And I also have that heat sinked here with silicone. So I'm using the driver as the input and the output to the laser diode. As for the load, I'm using a 33k ohm resistor and 3 wires to back that all up with some regulated excess current. I've got the input to the output pin connected via this green wire here. And I also have another positive input wire here to the adjustable pin, and another input wire directly connected here to the heatsink. And the negative power supply wire is connected to the negative pin of the laser diode. And the positive output of the driver goes directly to the positive pin of the laser diode. As for the laser module, it's really quite easy. I simply heat-sinked an access module to this heatsink here, and that helps keep everything stable during operation. And also helps eliminate heat waste. This device is classified as a Class 3B stationary laser, and I extracted the laser myself from a old Blu-ray player. The laser diode is fitted inside here, right next to the aperture head, and is focused again far down range. And inside is aerogel, which is used for insulation and thermal stability. And I'm also using thermal paste. What's interesting about this fluid is that it fluoresces against the 405 nanometer wavelength here. The laser in operation. Alright, so here I have that solution above the emission here. The energy state is going from a high energy to a lower energy. And there I have it in the beam there. Now that I have the laser focused down to a short range, I can show you what I can do to certain materials such as thin black plastic. So here it's poking holes straight through the material.